All right, so in this worksheet, you're going to solve inequalities. So notice these are inequalities. You have those inequality symbols and not equations. So you have greater than in this case, this is less than or equal to, and so on. So those are linear inequalities. All right. Now, remember when in our lessons when we talked about linear inequalities, you're for many, if not most of the problems that we dealt with, you're going to have an infinite number of solutions, right? So with a equation, a linear equation, for the ones that we dealt with, most of them, we had just one solution. For all of these on this worksheet, you're going to have an infinite number of solutions. So that's why you're asked to graph these solutions. Okay? All right, so let's look at the first one. And I think I have enough room to do that here. So here's the first one. You have this linear inequality. Okay, so notice I have parentheses, so I'm going to go ahead and use the distributive property. And so when I use the distributive property, there's your work. The directions did say to show work. See right here, show all work as presented in class to receive credit. All right, so to use a distributive property. So I get 6x minus 1 is greater than, when I distribute the 2, I get 2 times x is 2x. 2 times a negative 3 is a negative 6 plus 1. All right, now the next step, see on this side, I can combine like terms, those constants. So a negative 6 plus 1, that's a negative 5. So I get 6x minus 1 is greater than 2x minus 5. So that's where I'm at. So just like when you solved an equation, a linear equation, you bring all the variables to one side, constants to the other. Same thing, same approach for this one, except you're going to have, in this case, an infinite number of solutions. So let's go ahead and bring the variables to the right-hand side. So let me go ahead and subtract 2x from both sides. So 6x minus 2x is 4x. Minus 1 is greater than, and this is 0, a negative 5. So if this was an equation, the next step would be to add 1 to both sides. Do the same thing here with this inequality. You're going to add 1 to both sides, and I'm running out of room, so I'm going to put this here. So when I combine like terms, a negative 1 plus 1 is 0, so you get 4x. 4x is greater than, and a negative 5 plus 1 is a negative 4. And then finally, to get x by itself, just like if this was an equation, you would go ahead and divide both sides by 4. And when I do that, I get 4 divided by 4 is 1. 1 times x is x, so I get x is greater than, and then negative 4 divided by 4 is a negative 1. All right? So remember, I'm trying to find all real numbers of x that will make this inequality a true statement, that will make this side greater than this side. And there's no way you can look at this and come up with a solution. So you're writing equivalent inequalities to get to that point to where you can see what the solution is. The solution to the original is any real number that's greater than negative 1. All right, so you wrote equivalent inequalities to get to that point. So each of those, this one, this, and so on, it will, all those solutions will be this. All right, now we got to graph this. So notice there's no equal sign, okay? So in graphing, you're going to start with this number that you see right here. So x is strictly greater than negative 1. So we're going to put an open circle since there's no equal sign. Since negative 1 is not a solution because there's no equal sign, we're going to put an open circle. It's important that you indicate that as an open circle. And then we're going to graph every real number that's greater than negative 1. So the solution, the graph of the solution will be this. All right, don't forget your arrow though. All right, so you need an arrow on that side. So anything to the right of negative 1, any real number to the right of negative 1, all these decimals, all these fractions, every rational number greater than negative 1, every irrational number greater than negative 1 is a solution to the inequality, the original problem. All right. Now, as an interval notation, it's very easy to come up with the interval notation. So first of all, it helps if you have x on the right-hand side. I'm sorry, on the left-hand side. So since there's no equal sign, you're going to say parentheses. So open circle and parentheses are synonymous. Okay? So open circle, parentheses. So you're going to go from parentheses, -1. That's what you see here, right? So parentheses, -1, comma, all the way, and it's pointing towards infinity. All the way to infinity with parentheses. All right? And so there's your interval notation. So this graph, in terms of interval notation, is this. Now to write a set notation, that's easy as well. So you're going to use braces though. So this is how we read this. It's important you read this correctly. You're going to say the set, notice the brace, the set, and my variable is x. So the set of x's such that, so this vertical segment here, this vertical dash, you could call it, means such that. Such that. So the set of x is such that, and then there's your inequality. You just write your inequality. Such that x is greater than -1. And that's it. All right? So the set of x is such that x is greater than -1. So this part here comes from here. And then this part here comes from the graph. It can also come from here as well. X is greater than -1. No equal sign, parentheses -1 to infinity. Now, just to remind you, when writing interval notation, you always go from smallest to largest. So -1 to infinity. All right? Okay, now let's look at number 2. In number 2, I have 2 sets of parentheses, so I'm going to have to use the distributive property twice. So distribute the 3 here and distribute the 2 here. So 3 times 2x is 6x. 3 times a -3 is a -9. Don't forget you're also subtracting 5. That's important. Don't forget that. All right? Is less than or equal to, and then distribute the 2, I get 2 minus 2x. 2 times 1 is 2. 2 times -x is -2x. Let's combine like terms first on this side, because I can combine -5 and -9. So I get 6x minus 14 is less than or equal to 2 minus 2x. All right, let's go ahead and bring the variables to the left. When dealing with inequalities, it's very helpful if you bring the variables to the left-hand side. It helps. You don't have to, but it helps since I'm dealing with an inequality. So I'm going to go ahead and add 2x to both sides. Notice I'm aligning my like terms. And so remember, I'm trying to find the real numbers of x that will make this side less than or equal to this side. So that will make this inequality a true statement. There is no way you can look at this and come up with a solution set. So you have to solve this algebraically to get to that point. So we're writing equivalent inequalities so that I can get to x by itself. All right? So 6x plus 2x is 8x, minus 14 is less than or equal to, and when you combine like terms here, a -2x and 2x is 0, so 2 and 0 is 2. Adding 14 to both sides, so I have this very nice linear inequality now. So this is 0, so I get 8x is less than or equal to 14 plus 2 is 16. To get x by itself, we're going to divide both sides by 8. These 8's divide out. 8 divided by 8 is 1. 1 times x is x. We're going to put that here. So x is less than or equal to, and 16 divided by 8 is a very nice integer 2. So the solutions to the original inequality is any real number that's less than or equal to 2. All right, those are the only real numbers that will make this a true statement. So there's your solution. So your solution is any real number less than 2. In terms of the number line, see there's an equal sign, so 2 is a solution because there's an equal sign. So since 2 is a solution, and I just want to kind of show you something real quick. Let's see why 2 is a solution. I mean, you know 2 is a solution because it's an equal sign, right? But let's see if I substitute 2 into the original, why is it a solution? So let me just show you. So why is x equal to a solution? All right, so wherever we see the variable x, I'm going to substitute 2. So I get 3 times, and then 2 times 2, because x is 2, right? Minus 3 in parentheses, and whatever all this is, you're going to subtract 5, and you want to see if that's going to be less than or equal to, and then 2 times 1 minus x, and x is 2. All right, so let's look at this. In this parentheses, we're going to multiply before we subtract. So 2 times 2 is 4. 4 minus 3 is 1. So remember the order of operations, so multiplication before subtraction. So this becomes 3 times, so 4 minus 3 is 1, minus 5. 3 times 1 is 3, and 3 minus 5 is a negative 2, right? And then I want to see, is negative 2 less than or equal to, what's 1 minus 2? 1 minus 2 is a negative 1. 2 times a negative 1 is a what? Negative 2. So is negative 2 less than or equal to negative 2? It is. It's actually equal to it. See that equal sign? So that's why negative 2 has an equal sign, because it's a solution to the equation. Now remember though, whenever you graph this with the equal sign, you're going to put a closed circle. If there's no equal sign, open circle. If there is an equal sign, closed circle. So we need a closed circle at 2. Just like this. Make it look closed. Okay? And you want to graph every real number that's less than that. So you're going to shade in to the left with the arrow. All right? And so in interval notation, I remember with interval notation, always go from left to right. So from smallest to largest. So notice this inequality means that 2 is the largest. 2 is the largest. So you're going towards negative infinity. So you're going to say negative infinity to 2 with a bracket. Closed circle, bracket. Closed circle, bracket. Open circle, parentheses. Just to remind you, you may say, well, why didn't you put a bracket with negative infinity? And that's negative infinity, by the way. Why do you put a bracket with negative infinity? It's because infinity and negative infinity is always going to be parentheses, regardless if you have equal sign or not. All right? So never put a bracket with infinity, negative infinity. And then set notation, you're going to need this right here, the inequality symbol. So you're going to, the inequality statement, so you're going to say the set of x's such that x is less than or equal to 2. And that's it. All right? And then finally, the last one, number 3. So this is very similar to the first two. You're going to get rid of the parentheses. So let's go ahead and distribute both cases. So I get negative 3 times 2x is a negative 6x. And negative 3 times a negative 5 is a positive 15 plus x. See, don't forget that x is less than 2 times 2x is 4x, and then 2 times 3 is 6. Combining like terms on the left, I know that a negative 6x and a positive x, positive 1x, is going to be a negative 5x. I get negative 5x plus 15 is less than 4x plus 6. All right. Let's go ahead and bring the variables to the left-hand side. So I'm going to go ahead and subtract 4x from both sides, just like this. When I combine like terms, notice I'm aligning the like terms. When I combine them now, a negative 5x plus 4x is a negative 9x plus 15 is less than, see, aligning my inequality symbols. This is 0 and then 6. Subtracting 15 from both sides now, combining like terms, I get negative 9x is less than 6 divided by negative 15 is a negative 9. Okay? I'm going to go ahead and put that up here now. So negative 9x is less than negative 9. All right, now listen carefully what I'm about to say. So to get x by itself, you're going to have to divide both sides by that coefficient. So I'm going to have to divide both sides by negative 9. But remember, one of our properties that you learned in the lessons was that whenever you multiply or divide an inequality by a negative number, and I'm doing that here, I'm dividing by a negative number, you must reverse the inequality symbol. So negative 9 divided by negative 9 is 1. 1 times x is x. So I get x is greater, reverse, x is greater than, and then negative 9 divided by negative 9 is 1. All right? So whenever you either multiply or divide, in this case I'm dividing, both sides of an inequality by a negative number, both by negative 9, I must reverse that inequality symbol. So less than becomes greater than. And so you found the solution. So the solution to the original inequality would be any real number that's greater than 1. So notice there's no equal sign. So you're going to put an open circle on 1. So 1's not a solution. But every real number greater than that is. So there's your graph. There's the graph of the solution. In terms of interval notation, you go from left to right. So I'm going to start at parentheses 1, open circle, parentheses 1 to infinity. And then set notation, I ran out of room here, so let me go ahead and put that here. So set notation, you're going to say the set of x's such that, and then use this inequality, x is greater than 1. And that is it. Okay? So it's not a difficult process, but that's how you're going to solve linear inequalities. Make sure you know the process, how to get the variable by itself to find the solutions to the original. Make sure you know how to graph. Make sure you know how to write the interval notation and set notation. All right, so that's the key to that one.